Welcome, aspiring game developers, to this comprehensive tutorial where we'll learn to create a fundamental player movement script in Unity 3D using C# and Visual Studio. This guide is specifically designed for beginners, ensuring every step is clear and easy to follow, laying a solid foundation for your game development journey. Our primary goal today is to equip you with the essential skills to make a simple cube move around a 3D environment using just your keyboard's arrow keys. This seemingly small step is actually a crucial first step in game development, as player movement is a core mechanic in almost every interactive experience you'll create. This foundational knowledge of scripting player movement will open doors to understanding and implementing more complex interactions and game mechanics in the future. It sets you firmly on the path to building your own interactive experiences, from simple prototypes to fully fledged games, by mastering the basics of Unity and C#. Let's begin by setting up our Unity environment. First, you'll need to launch Unity Hub, which is your central management tool for all Unity projects. Once open, create a brand new 3D project, making sure to give it a descriptive name like Player Movement Tutorial so you can easily identify it later. Once your project loads, you'll typically see an empty scene, which is our canvas. We need two main elements, a player character and a surface for it to move on. To add our player, right-click in the hierarchy window, navigate to 3D Object, and then choose Cube from the options presented. After adding the cube, it's good practice to rename this new cube to Player for clarity and easier identification within your project. This cube will serve as our controllable character throughout this tutorial, and a clear name helps keep your project organized. Next, let's add a ground plane for our player to move across. Similar to adding the cube, right-click in the hierarchy window again, select 3D Object, and this time choose Plane. This will create a large, flat surface in your scene. It's important to ensure your player cube is positioned slightly above the plane to avoid any initial collision issues or the cube falling through the ground. You can easily adjust its Y position in the inspector window by selecting the player cube and modifying its transform component values. Now that our basic scene is set up with a player and a ground, it's time to create the C# script that will bring our player to life. In the project window, which is where all your assets are stored, right-click, select Create, and then choose C# script from the context menu. When prompted, name this script Player Movement, and then press Enter to confirm. It's absolutely crucial to name it correctly at this initial stage, as renaming script files later can sometimes lead to broken references and unexpected issues within Unity, requiring extra troubleshooting. With our player movement script created and named, double-click on its icon in the project window to open it in Visual Studio. Visual Studio is our integrated development environment, or IDE, where we will write and edit all our C# code for Unity. Inside Visual Studio, you'll observe a basic C# script structure automatically generated by Unity. This structure includes two key methods: the start method, which is called once when the script is first enabled, and the update method, which is called once per frame, continuously. For our player movement logic, we will primarily be using the update method. This is because we need to continuously check for player input and apply movement every single frame to ensure a smooth and responsive control experience for the player. First, let's declare a public variable for movement speed. This variable will control how fast our player cube moves. Type public float speed equals 5.0f above the start method. The public keyword makes it accessible from the Unity editor. Float specifies it's a decimal number, and 5.0f is our initial speed value. Making this speed variable public is a very useful practice in Unity development. It allows us to easily adjust the speed value directly within the Unity editor's inspector window without needing to reopen and modify the code every time we want to fine-tune the movement, saving a lot of time during testing. Now, inside the update method, we'll begin by getting input from the horizontal axis. This axis typically corresponds to the left and right arrow keys on your keyboard, or alternatively, the and D keys, providing left and right movement. We'll store this input in a float variable. Similarly, we'll get input from the vertical axis. This axis is responsible for forward and backward movement, and it's linked to the up and down arrow keys, or the W and S keys. This will allow our player to move in all 4 cardinal directions on the horizontal plane. These get-axis calls are fundamental to Unity's input system. They return a smooth value between -1 and 1, indicating the intensity and direction of the input. For example, pressing the right arrow key fully will give a value of 1, while pressing the left arrow key fully will give -1, and no input will result in 0. Next, we'll use these input values to create a vector 3, which is a structure used to represent 3D positions or directions in Unity. Type vector 3 movement equals new vector 3. This vector will define the direction our player should move. Notice that we explicitly set the y component of our vector 3 to 0. This is a deliberate choice because, for now, we only want horizontal movement along the x and z axis. Setting y to 0 prevents the cube from moving up or down, keeping it firmly on our ground plane. Finally, to apply this calculated movement to our player, we'll modify its position. Add the line transform.position plus equals movement asterisk speed asterisk time dot delta time to the update method. This single line of code is the core of our player movement logic, combining all the elements we've discussed. Let's break down this line. Transform.position refers to the cube's current position in the 3D world. The plus equals operator means we are adding our calculated movement vector to its current position, effectively moving the cube in the desired direction. Multiplying by speed scales our movement vector, allowing us to control how fast the cube travels. Crucially, we also multiply by time.delta time. This ensures the movement is frame rate independent, meaning the cube will move at the same speed regardless of how fast or slow the game is running on different computers, providing consistent motion. Once you've finished typing the code, it's essential to save your script in Visual Studio. You can do this by pressing Ctrl+S, or by navigating to File, Save All. After saving, switch back to the Unity editor, as Unity needs to compile the changes you've made to the script. Now that our script is written and saved, we need to attach this player movement script to our player cube in Unity. First, select the player object in the hierarchy window to bring up its properties in the inspector. Then, there are 2 easy ways to attach the script. You can simply drag the player movement script from the project window directly onto the player object in the hierarchy, or you can drag it into the inspector window while the player object is selected. Both methods achieve the same result. Once attached, you'll immediately see the player movement component appear in the inspector window for your player object. Within this component, you'll find our speed public variable, which you can now adjust directly using the slider or by typing in a new value, demonstrating the power of public variables. It's time to test our work and see our player cube in action. Click the play button located at the top center of the Unity editor to run your scene. This will switch Unity into game mode, allowing you to interact with your creation. Once in play mode, use your arrow keys or W, A, S, D keys to move the cube around. You should observe it responding smoothly to your input, moving across the plane you created. Experiment with different speeds in the inspector to see how it affects the movement. If your cube isn't moving as expected, don't worry. Troubleshooting is a normal part of development. First, double-check if the player movement script is correctly attached to your player object in the inspector window. A common mistake is forgetting to drag and drop it. Also, meticulously double-check your script in Visual Studio for any typos or syntax errors. Even a single misplaced character, like a missing semicolon, incorrect capitalization, or a misspelled variable name, can prevent the code from compiling and working correctly. Finally, ensure you saved your script in Visual Studio before returning to Unity. Unity only compiles and applies changes from saved script files, so if you forget to save, Unity will still be using the old version of your code, leading to confusion. Congratulations! You've successfully created a C# script to control a player cube in Unity 3D using arrow keys. This is a significant milestone in your game development journey, as you've now mastered a fundamental aspect of interactive game design. Today, we covered several crucial steps: setting up a basic scene with a player and ground, creating and writing a C# script in Visual Studio, understanding the start and update methods, and finally, applying that script to a game object in Unity. This is just the beginning of your exciting game development journey. From this foundation, You can explore adding many more features, such as implementing jumping mechanics, creating a camera that follows your player, or even integrating complex character animations to bring your game to life. Keep experimenting with the code, keep learning new Unity concepts, and most importantly, remember to have fun building your own unique and engaging games. The possibilities are endless, and every line of code brings you closer to realizing your creative visions.